Algebraic expressions or algebra. In algebra, letters are used to stand for numbers. When letters are used to stand for different numbers, they are called variables. Letters which have fixed values are called constants. So, example, like 2 pi r squared h, we are saying that r and h are what? Variables, because they can change. Okay, but 2 and pi are constants. Why? Because they cannot change. Okay, so an algebraic expression is a collection of letters and symbols combined with at least one of these operations, either plus or minus or times or division. Okay, all right. So the terms in an expression are separated by plus or minus signs. So we can have a term like, let's say 3x, 5y, and let's say 6. And then what we are saying is these signs can separate them. So plus can separate it and then minus, okay? Or it can be minus or plus, okay? All right, so that's what we are saying. All right, so the number placed in front and thus multiplying a letter or group of letters is called the coefficient. So let's say we have 7y. What we are saying is the number placed in front of the letter is what? Coefficient. So 7 is what? The coefficient. Okay. So in like terms, the letters and powers of each letters must be the same. Okay. So for example, 3s squared y and then minus 4s squared y are the same. Okay. All right. But then example like 3s squared y and minus 4sy squared are not the same. Okay, these are the same because numbers, s squared, y, and then y. But this is not the same as this because the squared only affects what? The x. This time around, there is a squared after the sy, so they are not the same. Okay, all right. So s is having squared, s is having squared, y is having nothing, y is having nothing. S is having squared, y is having nothing. S is having nothing, y is having squared. So they are not the same. Okay, so forming algebraic expressions. So statements in words are often written as algebraic expressions in mathematics. Any letter may be used for the unknown number. A different letter must be used for each different unknown. So simple logic is usually all what is required to translate a set of instructions into an algebraic expression. So we are saying simplification of algebra has four rules of addition, subtraction, multiplication, and division. We are going to tackle addition and subtraction. Then we'll move to multiplication and division. So only like term can be added or subtracted to give a single term. It is often called collecting like terms. Expressions often contain several sets of like terms. It is very easy to simplify if we rewrite the expression with the like terms next to each other. So that's what we are going to do. So with our first example, what we are saying is very easy to work algebraic expressions or algebra when we group like terms together. and then work them out. Okay, so that's what we are going to do. So 5x, we've taken this 5x. Okay, there is 3x here. And then it comes with what? Plus, positive sign. So 3x. Now we go to what? Letter y. And then we have y here. So minus 9y. Okay, you cancel so that you know that you've taken that out. Okay, that's why I keep canceling. Okay, so minus 9y. Then we have what? 2y, but it comes with what? Plus 2y. Okay, and then also we have plus 4 and then minus 7, and we cancel. Okay, all right, so let's continue. So 5x plus 3x will give us what? 8x, then minus 9y plus 2y, because there are different signs you have to subtract. So when we subtract 2 from 9, we get what? 7. So 7y. We look at the bigger number. What is it? 9. What number is attached to it? Negative. So we bring it negative. When we subtract 4 from 7, what are we going to get? 3. We look at the bigger number, 7. What sign is attached to it? Negative. So we bring negative. There's our final answer. 8x minus 7y minus 3. Okay, so we have the second question here. The same process. We are going to group like terms. We have 4s. We have plus 3s. We cancel plus 3s. Okay. All right. We have plus 2y. We have plus 5y. All right. 4s plus 3s is 7x. Okay. And then this time around we all have plus plus, so no need to worry. Just add plus 7y. So 7x plus 7y will be our final answer. Okay, so we have another beautiful question here. Okay, so the same process. We'll group like terms and then we continue. So algebraic expression is very easy. One of the easiest topic I love in math. Okay, all right. So 2p, we cancel. Let's look for a p. So it comes with what? Plus 3p, cancel. And minus 3q, then plus 5q. Alright, so 2p plus 3p is what? 5p, and different signs, minus and plus. So we do what? We subtract. Always remember, when there is different signs, we subtract. The same signs we add. Okay, so we're going to subtract. So 3 from 5 will give us what? 2. And then letter kill. Number 5 is the biggest. Looking at these two. Okay, now what sign is attached to it? Plus. So we just bring the plus here. So 5p plus 2q will be the final answer. Okay, so we have two more beautiful questions. Let's finish them up. Okay, so let's group the like terms. First of all, for s squared y, we cancel. Let's look for s squared y. There's sy, no, s squared y. Okay, so this, it comes with what? A plus, so plus 3s squared y, then we take it out, then plus 5sy squared, take it out, minus 2sy squared, take it out. Okay, all right, let's add them. 4 plus 3 is what? 7, then s squared y, then different signs, so we do what? We subtract. What are we going to get? 3. and what? S y squared. 5 is bigger than 2. It has positive sign attached to it, so plus. That's it. So we have 7s squared y plus 3sy squared. Okay, let's do number 5. Okay, so we have s squared and then we have another s squared, but there is 2 here. There is an invisible 1 here, but just forget about it and then you just write s squared. Okay, comes with plus 2s squared, then this follows plus x. Continue to add this. So invisible 1 plus 2 is what? 3. And then s squared plus your x. Done. Okay. Okay, so we move on to multiplication and division. When multiplying or dividing expressions, it is easier if you group the numbers and the same letters together and then use the basic rules of indices. So the only difference between addition and subtraction and the algebra and the multiplication and division is that with multiplication and division, the basic rules of indices apply here. Okay, that's the only difference. Okay, so we should know that a bracket may be used to show a multiplication. That is, when we have a bracket open or parenthesis open, bc bracket close means a multiplies what? The bc. Okay. Okay, so we are saying the only difference is the laws of indices, basic indices will be applied here. So if you have forgotten about indices, kindly write under the comments and then I'll go over it. Okay, all right. So 4 times 8 is what? 32. So basic laws of indices or rules of indices. When there is a multiplication sign, we do what? We add the powers. When it's division, we do what? We subtract. This time around, there's multiplication, so we do what? Add. Whenever there is a variable, know that there is what? And then there is no number, there is no power, know that there is what? Invisible 1. Okay, so there is 1 here, but it's invisible. We just add 1 to 2. We get what? P raised to the power 3. So this will be our final answer. Okay, we have another second question. We have minus 2a times 4c times 5b. Very simple multiplication. So the constant, let's multiply them. 2 times 4 is 8. 8 times 5 is what? 40. Then we do what? We multiply these. We add all of them because invisible 1, invisible 1, invisible 1. So a, b, c. Okay, someone will ask why didn't I write A, C, B since we are flowing in order. Now, when we are calling alphabet, we don't say A, C, B, we call A, B, C, D, E, F. Okay, so that's why we just wrote it that way. We can write it A, C, B, but just try to make it beautiful. Okay, all right. Remember, there is a negative sign here, so just add it to it. And you're done. Very simple. Negative 40 ABC. We have another beautiful question here. Okay. 5 times 4 is what? 20. Okay. S and then S. Multiplication. So we are doing what? Adding. Good. All right. Invisible 1 and then 4 will give us what? S. 5. Because 1 plus 5. 1 plus 4. Sorry. Okay. All right. Let's move to Y. So we have 2 and then we have 3. When we add, we get 5. 20s raised to the power 5, and then y raised to the power 5. Okay, this time around, let's work something in a division form. No more multiplication. Okay, so let's see. Okay, so 16 divided by 2 is what? It means one number when multiplied by 2, we will get 16. Okay, that means 8, right? Okay, and we said if it's division, we are gonna subtract. Okay, so write a. There is a cube here, or a raised to the power 3, and then a raised to the power 1. Subtract 1 from 3, you get what? 2. And then b 2. Then there is 1 here. Subtract that 1 from the 2. What are we going to get? 1. But we're not gonna write. So final answer is 8a squared b. Okay, so let's do this last example and then move forward. Okay. All right, so the same way, 15 divided by 3 is what? 5. Then y, okay, we subtract 1, but we don't write it. So 5y. Very easy, okay? Okay, so we move to the next subtopic, removing brackets. So brackets are used to group terms together. An expression with brackets in A can be replaced by an equivalent one without brackets. This is called removing the brackets or expanding the expression. To remove the bracket, we use the distributive law. So we multiply the term outside the bracket by each of the terms inside the bracket. So let's see, we have something like, for example, we have 4a plus 3. So we are saying we will use the distributive law. So 4 times 2 is what? 8. 8 times a is what? A squared. Then plus 4, 3, 12, and a. Final answer. That's what it means. Okay. All right. So we move on. We should take care with the signs when removing brackets. Note that a letter or number without a sign has a plus sign. Okay, so whenever there is any number there and then without any sign, just imagine that it has what? A plus sign. So let's say there is 2a just lying there. You know that automatically or naturally has a plus. Okay, so let's say 40y is there. You know that there is plus attached to it. Okay, all right. Let's say 7 is just there. Know that there is a plus sign. Okay, all right. So when there is a negative sign in front of the brackets, the signs inside the brackets change when the brackets are removed. So let's see, we have example like minus 2a, b minus c plus d. Okay, so what we are saying is when there is any number and then there is no sign, there is an addition sign attached to it. Okay, but then any number that has a negative sign and then used to multiply a variable or a number inside the bracket, know that that sign will change. Okay, so I'll explain. We are multiplying through negative 2a times b will give us what? Negative 2ab. Negative 2a times negative c. Negative, negative, positive. So positive 2ac. Okay. Negative 2a times plus d. Negative, positive. So negative always overcome it. We have what? Negative 2 AD. That's what we mean. Okay. All right. So we are continuing. You should also know that negative 2AB times B is equal to negative 2AB. Okay. All right. And then we should also know that negative 2ax minus c is 2ac. Okay, why? Because negative negative is what? Positive, but negative positive is what? Negative. And then lastly, you should know that negative 2a times d is negative 2ad. Okay, all right. Okay, so we should know this, that when we are multiplying and then there is a positive number, and then positive number, the final answer will be positive. Negative times negative, we get positive. Negative times positive, we get negative. Positive number times negative number, we get negative. So I remember when I was a kid, we used to say positive is what? Po, nege, nege, po, nege, po, nege, po, nege, nege. What am I saying? It's kind of African. So uh, negative is shortened as nege, then positive is shortened as po. Okay, it'll sound funny until you need it. So let's try to imitate if you can and if you are willing to. So po po po, nege nege po, nege po nege po, nege nege. All right. Okay, so we are jumping to working some examples. I'll try to give maybe 6 or 7 examples, and then we move on to the next topic, subtopic under algebraic expression. Okay, so quickly, we are told to simplify the following expressions. So what we need to know is when we are told to simplify an expression with brackets in it, we should remove the bracket first and then collect all group like terms before we either add, subtract, divide, or multiply. Okay, whenever we follow instructions, math is very, very easy. Very easy. Okay, so let's follow instructions. It says remove brackets first, group like terms, add or subtract, divide or multiply. Very simple. Okay, all right, so there are brackets here. We need to take them out. 4 times x is what? 4x. Then plus 4 times 1, 4, plus 2 times 2, 4. There is x, so x. And plus is what? Plus. And then 2 times 1 is what? 2. We've taken all the bracket out. Okay, all right. Now let's group like terms. 4s, we cancel, plus 4s, take it off, plus 4, take it off, plus 2, take it off. Finally, 4 plus 4 is 8, there is x, and plus 4 plus 2 is what? 6. Final answer. Okay, all right. Do not get confused that, oh, why didn't we add the x and then s? No, we are not dealing with multiplication or division. Okay, we are dealing with what? Addition here. So just concentrate on the constants. Add them and pick one of the x, put it down there, and add 4 plus 2. You are done. Okay. Okay, so we move to the second question. We are multiplying negative 3 by 2x by negative 4. Okay, so we said negative is what? Negative times positive is what? Negative. So negative 3 times 2 will give us what? Negative 6s. Then we said negative 4. Negative times negative is what? Positive. So we get what? Plus 3, 4, 12. Answer. It's very easy. Negative 6s plus 12. So we have another third question. There's a bracket. The rule said take away the bracket, group like terms, and then continue with your working. So you have to take off the bracket. So okay, 5a plus 2 times 2 is what? 4a. Positive and negative will be what? Negative. So negative 2, 3, 6, and plus 4. We've taken the bracket away. And so we'll group like terms. 5a plus 4a. Luckily for us, it has already been grouped, so no need to worry. Just analyze things by adding 5 and then 4 to be 9. You bring the a. And then different signs, negative and positive. So we'll do what? Subtract 4 from 6. Give us what? 2. 6 and 4, which number is bigger? 6. Then sign, which sign is attached to it? Negative. Bring it here. Okay, that's it. 9a minus 2 will be your final answer. Okay, so we continue to question 4. All right, so we have removed the brackets. Know that when there is no number, there is always invisible 1. Okay, all right, so 12b negative 1 times 5 is what? Negative 5. Because negative 4 is negative. And negative 1 times positive 2b is what? Negative again. So negative 2b. Okay, and bring your minus 7. I hope it's understood. There is 1 here, so negative 1 times 5 is negative 5. Negative 1 times positive 2b is negative 2b. Okay, all right. Let's group like terms. 12b, there is minus attached to it, so minus 2b minus 5 minus 7. All right, finally, let's subtract. We got what? 10b, the same signs, negative negative, so we will add. Okay, 7 plus 7, and then 5 will give us what? 12. Which sign affects the bigger number? Negative 7, so we'll bring the negative here. Okay, 10b minus 12 is the final answer. Okay, so the fifth question, question 5. We take off the brackets. Of the brackets, so 4 to 8, 80, 4 times 1 is 4, minus 3t, negative negative is what? Positive, 3, 2, 6. Okay, all right, let's group like terms. 80 cancel, minus 3t cancel, plus 4, take it away, plus 6. Okay, final answer will be 5t, then plus 10. Final answer. Okay. Now question 6. We took away the brackets. 3a times a, 3a squared, because a times a is what? A squared. That's why we had a squared. Okay. All right. Okay, so plus 3, 4, 12. A times a is a squared, and there is b, just add it. Okay, all right. 3a times b times negative b. Positive negative is what? Negative. So negative 3ab. Okay, All right, let's see. Like terms 3a squared, 12a squared b 3a. They are all different, so this will be the final answer. Okay, because they are not the same. If you remember when we were starting, we made mention of that. They are not the same, so this will be the final answer. Okay, let's do the last example. Okay, with this example, we have two brackets. Okay, and then it's said that when there are brackets inside a bracket, okay, we always remove the bracket inside the bracket first. Okay, so there is first brackets, and then there are another brackets. What we are saying is we will remove those inside the brackets. Then these brackets will be the last to remove. Okay, all right, so let's remove the bracket first. What is inside there? So we have, when we multiply 1 through, we get a plus 3b, okay, plus 4 to 8a, then minus positive will be what? Minus 4 times b is what? 4b. We have removed the first bracket. Okay, all right. Before we remove the second bracket, let's try to group the like terms inside it. We have a here, and then we have plus 8a. Okay, then we have plus 3b, and then we have what? Minus 4b. Let's clean up inside the brackets. We just add them. So 1a plus 8a is what? 9a. Different bracket, different signs. Sorry, different signs. So we do what? We subtract. Okay. So 3 from 4 is what? 1. And then there is b. 4 is bigger than 3. And then it has a negative sign. So you would apply here. Okay. All right. Let's bring the bracket. Now we are going to take this bracket away. Okay. All right. So 2 times 9 is what? 18. A times a is what? A squared. Okay. Positive and negative. Negative. Okay. 2 times 1 is what? 2. Then a times b is what? ab. So 18a squared minus 2ab. Okay, so we move to algebraic fractions, and then what we are saying is working with algebraic fractions involve the same method as working with ordinary fractions. So if you've watched my fraction video, this will be very easy for you because it's the same thing. Okay, so multiplication and division. To multiply algebraic fractions, just multiply the numerators and denominators separately. Okay, all right, so for example, we have something like a over b times x over y. What we are saying is just multiply the numerator, so ax over and then denominators by. Easy. Okay. All right. So before multiplying, cancel any factor common to the numerators and denominators. This makes the multiplication easier. Always check that your answer is in its simplest form. Whenever we are dealing with fractions, we know that we have to break things down to its simplest form. Okay, all right. So our first question, 12sy over 7 times 14x over 20. So we said when we have something like that, it's just like a fraction, working on the fractions. We can just multiply through 12 and then 14, get the answer for the numerator, and then 7 and then 20 for the denominator. We are done. But it's also said that whenever we are dealing with anything concerning fractions, we need to break things down to its simplest form. Okay, so looking at this, 12 over 7, 14 over 20, we can do some cancellation before we put ourselves in a big situation trying to multiply 12 by 14 to have a bigger number, then 7 times 20, bigger number, then you go and cancel. Now, we can do things simple here, okay? So 7 goes here 1, it goes here 2, okay? 4 can go here 5, can go here, how many times? 3. You see, we've broken things down. Now we have 3 times 2, which is what? 6. We have s times s, which is what? S squared. We have y times 1, which is what? Y. Invisible 1 here. Remember, you multiply with the y, you get y. Okay. Over 1 times 5. 5. Final answer. Okay, so let's go to this second question. Quickly, we do some cancellation. 3 goes here 1, goes here 3. Okay. 5 goes here 3, goes here 3, goes here 2. All right. So 1 times 2 is 2, A, then B, then D raised to the power 4. All over 3, 3, 9. Always let's mention from A, then B, then C, then D. Okay. We can just write C, D, cube, A squared. That is not beautiful. Okay. All right. So we have A squared here. Right. A squared first. Let's search for B. We don't have any B. And we have C, so C squared, then D cube, or D raised to the power 3. This would have been our final answer, but then remember that we said when there is division sign, we subtract powers of the same like variables, and then we have a here, and then we have A here, like variables. So we are going to subtract. We have C, we don't have C here. We have B, we don't have B here. So they are out. We have D, we have D here. So we subtract what? The 3 from the 4. Okay. So you may have a question, and then one of the options would be this, and then the other option would be a simplified version of this. If you opt for this, you are wrong. Okay. Why? Because anything under fraction needs to be simplified. Then that is what we go for. Okay. All right. So quickly, let's simplify this. Okay. So we are subtracting because it's division sign. Remember, when it was to be multiplication, what we will add the powers. Remember? Okay. All right. So A invisible 1 subtracted from A squared, we got what? A. And so this A will be cancelled. And right now we have what? A1 here. I hope I didn't confuse you. All right, I'll go over again. So we have 2A, and then we have square. So what we are saying is A1 minus A squared can also be written as A squared minus A raised to the power 1. When you subtract this one from 2, you get what? 1. So write A1. But then we don't write A1, we leave it like that. Okay. And so if you've left it like that, that means the one that had that one will vanish. And this 2, because 1 is taken from it, will be termed as what? 1. But we don't write there 1. So A, which is what? A. So that's what we did here. Okay. So this will cancel. This will turn to be what? A1. But we don't write the 1. So the final answer, we're not going to write the 1. Okay, so quickly, B is here. We don't have any B here. So we ignore C squared. We don't have any C here. We ignore. Okay, so D and then D4. Let's subtract 3 from 4. We get what? 1. So the least will be gone. Okay, and this will be D1, but we don't write it. So let's finalize it. So 2B D, we don't write a 1, okay? Over 9A, we don't write a 1. Just leave it. C squared. Simple. So if you go over the video and still you don't understand it, please comment. I'll go over only this question, explain it again, and then upload it for only you. Okay? But this the final answer. 2BD over 9AC squared. Okay, so we have another beautiful question here. Okay, I know someone will be looking at it right now and they will be like, oh, come on, this is getting nasty. It's a difficult question. That is why I hate math. No, calm down. You don't hate math. We just have to follow instructions on the math, and then it will be equally easy for us, just as other subjects we love. Okay. All right. Okay. Quickly. Um, 6x squared plus 2xy all over 5z times 15z squared over 3x plus y. Kind of like confusing, but we need to be a little smarter. So what we are going to do is try to bring brackets here for us to get the same 3x plus y. Then we can just cancel. Okay. All right. I'll show you what I mean. Okay. So we can use 2 to simplify through for us to get something like this. Okay, so 2 will be out, s squared. Let's divide it. Put 1x there, open bracket, 2 times one number will give us 6, 3. Okay, remember we had s squared. We divided 1s out, 1x in, plus, okay, so 2 times what will give us 2sy, 1, invisible 1. There is already x, so we just put what? Y. Okay. Okay, so if you have something like this, 2s, 3x plus y. Remember, we said when we are dealing with algebraic expression, we have to do away with what? The brackets. So let's do away with it and see if we get the same thing. So 2 times 3 is what? 6. S times s is what? S squared. Then plus 2s times plus y is what? 2xy. We have the same thing, right? Okay, so this is the same thing as this. Okay, all right. So right now we have 5z and times 15z squared over 3x plus y. Now 3x plus y can cancel 3x plus y. Okay, all right. 5 can go here, 1 can go here, 3. Z can cancel, this will be away, and then we have z squared, so we'll be left with what? Z1. Okay, because this one has taken one of it and then remain what? One of it. So we can go on and then write what? 2x over 1 times 3z over what? 1. Why? Because under fractions, when any number is just lying down there, know that it's over 1. So right now we have 3z under fraction, so it's what? 1. 2 is just lying there, but it's under fraction, so it's what? Over 1. Okay, all right. All right, so we have 2x over 1 times 3z over 1. All right, so let's finalize things. We need to multiply through. So 2 times 3 is what? 6. S times z is what? xz all over 1 times 1 is what? 1. So this can also be written as 6xz. Final answer. Okay, very easy. Okay, so we move into division under algebraic um, expressions and then subtopic algebraic fraction. So to divide an algebraic fraction, we multiply by its inverse. Okay, so what we mean is when we have a division sign here, a over b divided by x over y. If you've already watched my fraction video, you know that we spoke about whenever we change a division under fractions, then the next fraction we do what? The denominator turns to be the numerator and the numerator turns to be the denominator. The same thing applies to this because we are dealing with what? Fractions. So this will be written as a over b times, and y will be the numerator, then s will be the denominator. And then we can go ahead, multiply a times y to get ay over b times x to get bx. That's what we're talking about. Okay, so with this question, we have a division sign here, we change it to multiplication, and then inverse this 9 to be numerator, and then 5ab plus 10b squared to be denominator. Okay, all right, so 4a squared plus 8ab over 3 times then 9 or 5ab and b squared. Okay, all right, the next thing we have to jump to factorization. I hope you remember factorization. If we don't, please comment and then I'll go over that. Okay, all right, so factorization. Okay, 4a will come out, a squared, 1a is out, so the left a will be in, plus 4 times 2 will give us 8. Okay, there is already a here, but there is no b, so we just put b. If we should work this out, 4 times 4a times a is what? 4a squared plus 4 to 8 ab. See, we've gotten the same thing. All right, so that is factorization. Okay, so over 3 times 9. The idea is to get the same thing here, a plus 2b. Okay, just cancel. Okay, all right, so let's try to get the same thing here, a plus 2b. Okay, that's very smart because we want the same thing so that we can just cancel. So we just put the same thing here and then try to work our way out. So we have 5ab. Then we have to bring 5b out so that when we multiply 5b times a, we'll get what? 5ab, which is equally this. Okay, then plus 5 to 10, b times b, b squared. Get the whole thing. All right. So a plus 2b, a plus 2b, it will cancel. Okay, all right, let's see. 3 can go here, 1 can go here, 3. We cannot cancel again, so you write 4a times 3 is what? 12a over 1 times 5b is what? 5b. So 12a over 5b, final answer. You know what? There is division, but there is what? Unlike variables. So if there was to be another a here, what are we going to do? Subtract. So we would have cancelled the a's. But different variables, a and then b. So we leave the answer to be like this. So 12a over 5b is our final answer. Okay, so we move to addition and subtraction. Okay, all right, and then I think that will be our last subtopic under algebraic fractions. Okay, so we are saying that when we want to add or subtract algebraic fractions, we find the LCM of the denominators first before we work them out. Okay, so we have a minus b all over 3 plus 3 over 2. What we are saying is find the LCM of 3 and 2, which is what? 6. Okay, 3 goes into 6 times 2. So that 2 will be used to multiply A minus B. And this unit sign 2 goes into 6 3 times, and then will be used to multiply the 3A. Very simple. Okay. All right. So 2 times A is what? 2A minus 2 times B is what? 2B, because positive negative is what? Negative. Okay. Plus 339A. Okay. All over 6. Now we group like terms. So 2A plus 9A, then minus 2B, all over 6. So when we add 2 and then 9, we get what? 11A minus 2B over 6. They all have different variables, A, B, nothing, so we can't continue working. That's final answer. Okay. Okay, so second question, 2x minus 1 over 3 minus x plus 3 over 2. Find the LCM, which is 6. 3 goes here 2, so we use the 2 to multiply the whole numerator, which is 2x minus 1. Then minus 2 goes here 3, so we use the same 3 to multiply 3 plus 3. Okay, 2, 2, 4x minus 2 times 1, 2 minus 3s. Negative, positive is what? Negative, so negative 3, 3, 9. Okay, all over 6. All right, let's group like terms. So 4x, 3x minus 3x. So minus 3x minus 2 minus 9 all over 6. So when we subtract 3s from 4s, we get what? 1s, but we are writing what? X. Okay, minus 2 minus 1, minus 9, the same sign, so we add. So 11. 9 is the bigger number, it has a negative sign, so we put negative here. Or 6. Different variables, x minus 11 all over 6. Final answer. Okay, very simple. Okay, our last example. We have 5 over 6r minus 3 over 4r. It's kind of interesting. Why? Because there is a variable added to the denominators, but it doesn't change anything. Okay. All right. So let's find the LCM, which is 12. But there are r, so you just pick one. Okay. All right. 6 goes into 12 2. Then 2 times the 5 minus 4 goes into 12 3. Now 3 times that 3. Okay. 2 5 10 minus 3 3 9 or 12r. Then we subtract, we get 1 over 12r. Final answer. Alright, so this will be the last thing to do under algebra or algebraic expressions.